the last integration technique is called partial fraction, and this is what we are going to discuss in this recorded lecture. So what is partial fraction? All right, the partial fraction is actually a method used for integration like this. Okay, so now when we have 1 over x minus 3 plus, okay, minus 1 over x minus 2. Okay, now how do we solve this one? First, we are going to form the common denominator by multiplying these two. So the first one, we are going to times x minus 2, all right, top and bottom. So we will have x minus 2 here. And the second one, we're going to multiply x minus 3. So multiply top and bottom, and here we have minus x minus 3 here. Now for the bottom one here, if we expand, we will actually get x squared minus 5x plus 6. And for the numerator, we will have x minus x, which is 0, and negative 2 plus 3, which is 1. Okay, we have x minus 2 minus x plus 3. So this gives us 1 over x squared minus 5x plus 6. Okay. Now, so when we try to solve this, we actually combine and form the common denominator and we solve. Now, partial fraction is actually, we are working on the reverse way. So what do we do here is we are actually moving the reverse way. We try to decompose this one into the addition or subtraction of two fractions. Okay, so this is partial fraction. We try to decompose something like this to something like this. Okay, and when we actually decompose this one, so it makes our integration easier. Okay, so let's see what should we do to decompose this one. All right, to this. Okay, so now first we know that x squared minus 5x plus 6, this denominator, it can be factorized into 2, which is x minus 3 and x minus 2. Okay, so then we write the partial fraction. All right, so 1 over x squared minus 5x plus 6 is equals to a over x minus 3 plus b over x minus 2. Okay, so a and b, they are actually the function of x, which at the moment we don't know what is this. We are going to find the a and b. Okay, so now how to find the a and b? Now we know that when we actually form this, combine this into one fraction, we have x minus 3 and x minus 2, right? So the first fraction here, we multiply by x minus 2, up and down. And the second one here, we multiply with x minus 3, up and down. So in this case, we have here, right, the a multiply x minus 2 plus the b multiply x minus 3. Okay, so when we combine these two, we will get something like this. And when we compare, okay, what we have, okay, compare here, this one with this one. Now this x minus 3, x minus 2, when we expand, we will get this one, x squared minus 5x plus 6. Okay, so we know that this a multiply x minus 2 plus b multiply x minus 3 will give us 1. Right? Therefore, we have a basic equation here. All right, this one is equals to 1. Okay, now so from here, then we can try to find the A and the B. Okay, first, how to find the A and the B? Now, we know that when x equals to 3, when the x is 3, so 3 minus 3, this will give us 0, right? And then we can eliminate the B. So here will be 3 minus 2, and we have 1A. 1A is 1, all right, this is 0. Okay, so in this case, right, we are going to let the x be 3. So we have 0 here. Okay, and 1A equals to 1, then we can find that A is 1. Right, so from here we solve for A. Now to solve for B, what should we do? Okay, so this is the x, right, x minus 2. And this is x minus 3. So what should we do to solve for B? We should let this one be 0. So the x should be 2. Okay, so we let the x be 2. So when the x is 2, so we have 2 minus 2, we get 0. And this is 1, we get negative 1, B. So in this case, the B is negative 1. So when we have A and B, now we can substitute back to the equation here. All right, remember before this we have A over x minus 3 minus B, okay, plus B over x minus 2. So substitute the A is 1 and substitute the B is negative 1. Okay, the B is negative 1. So now we can decompose this into 2 fractions. Okay, so this is called partial fraction. Now, next we are going to use this method to integrate 1 over x squared minus 5x plus 6. So first we decompose this one to 1 over x minus 3 minus 1 over x minus 2. So we differentiate them separately. So we integrate them separately. So when we integrate this one, okay, we know that this is actually absolute of x minus 3. Okay, follow the formula if we have integration of u prime over u du. So this will be ln absolute u plus c. Okay, so this is x minus 3. Differentiate x minus 3, we get 1. So this is the u. This is the u prime. So when we have, okay, this pattern, so we get, after integration, we get the ln. Okay, so minus, then follow this, we have ln absolute of x minus 2 plus c. Okay, let us consider another example, a more complicated example here. Okay, we want to integrate 2x to the power of 3 minus 4x minus 8 over x squared minus 8 and multiply x squared plus 4. Okay, now first, before we continue, right, we consider this function here. Now, can we factorize the denominator? Okay, so we know that this denominator can be factorized into x. Okay, we can factorize out the x. We have x minus 1 and x squared plus 4. Right, so x minus 1, x squared plus 4. And now we can actually split this function into 3 different functions. So we have a over x, b over x minus 1, okay, and now I want to highlight the last one. Now the last one is actually, the last factor here is actually x squared plus 4. So when we write the numerator here, it will be 1 degree less than denominator. 1 degree less. Okay, 1 degree lesser. Now, this is x squared plus 4. Therefore, for the denominator, for the numerator, it will be cx plus d. Okay, so the power is 1 here. 1 degree less than the denominator. Okay, so if this degree here is power 3, then here we need to create up to square. We have cx squared plus dx plus e, if this is power 3. Okay, so the numerator is always 1 degree lesser than the denominator. Okay, now, so from here, we can actually create the basic equation. So we know when we combine this, what happened to the A will actually multiply x minus 1 and will multiply x squared plus 4. And what happened to B? The B will actually multiply the x, okay, and also x squared plus 4. And for C, for the third one, cx plus d, it will actually multiply x and x minus 1. So we have, okay, cx plus d multiply the x, multiply x minus 1. Okay, so, and this is equals to 2x to the power of 3 minus 4x minus 8. Okay, so this become our basic equation. All right, so we have the basic equation as this. Now, again, we are going to eliminate the A, B, and C and D one by one, all right, to find the A, B, C, D. Okay, so how to solve for A? If we want A, okay, we want to find A, what should we do? So we can let the x be 0. So when the x be 0, we have 0 here. So we can eliminate the whole term. And when we have a 0 here, okay, so multiply 0 will actually eliminate the whole thing. Alright, so we let the x be 0 so that we can get the value of A. Okay, so let the x be 0. So substitute 0 here. Okay, we have 2 multiply 0 to the power of 3 minus 4 multiply 0 minus 8 equals to A. We have 0 minus 1 and 0 squared plus 4. Okay, for this one, of course, when we have B multiply 0 squared plus 4, we get 0. And for this one, of course, when we have 0 here, when we multiply, we get the 0 for whole term. So we get plus 0 and plus 0, right, for the second and the third term. Okay, so on the left-hand side here, we have negative 8. And on the right-hand side here, we have A multiply negative 1 multiply negative 4. So we will get this. Now, from here we have negative 4A is equals to negative 8 and the A is 2. Okay, so this is actually how we solve for A. Okay, now, how do we solve for B? How do we find the B? Okay, to find the B, we want to eliminate the A. We want to eliminate the C and D. So what can we do? We can actually let the x be 1. So when we have the 1 minus 1, we have 0 here. and the first term becomes 0, and when we have 1 minus 1 here, we can eliminate the third term. Okay, the second term here, when the x is 1, it does not affect it. Okay, so we can let the x be 1 to find the b. So on the left hand side here, now we have 2 times 1 to the power of 3 minus 4 times 1 minus 8. Okay, here we have b 1 square plus 4. Okay, so now when we solve, then on the left hand side we have negative 10. On the right hand side we have the 0 for the first term. Okay, and for b here we have 5. Okay, so this is 5 times 1 times b, so we have 5b. Okay, and for the third term here we get 0 as well. Okay, and from here, solve for b, we have b is negative 2. Okay, and finally we want to solve for c and d. Okay, now how to solve for c and d? Okay, to solve for c and d, we can actually use the value of a and b we obtain. So the value of a is 2, and for value of b is negative 2. Okay, we can actually use this value and we substitute the value for x. Now, we can, since we need to solve for c and d, two variables here, okay, and x squared minus 4, okay, we want to solve for two variables here. To solve for two variables, we need two equations. Okay, remember, right, in the system of linear equation, if we want to solve for two variables, we need two equations. And also, since this x squared plus 4, it cannot be 0. Okay, we cannot make this one 0 because this is always positive. Therefore, we can actually substitute any value of x. Okay, you can use any value of x, choose 2. So to create two equations from here. Okay, now let's see. So, for example, now let's choose x equals to negative 1. And we are going to substitute the a is 2 here. And the b is negative 2 here. So when the x is negative 1, okay, on the right hand side, when we substitute negative 1, we get negative 6. And on the right hand side, of course, when we substitute, we get something like this. So, solve this. We actually have, right, negative c plus d equals to 2. So we have one equation. Okay, now after that, okay, we choose another value of x. So let's choose x equals to 2. Alright, and again we substitute into the equation here. Okay, substitute into this equation. Now the x is 2. Okay, so we have a 2 here. 2 times 2 to the power of 3 minus 4, 2 minus 8. And for the right hand side, the a is 2. And we have 2 minus 1, which gives us 1. This one is 2 squared plus 4, we have 8. Okay, and we have negative 2 here. The x is 2. And 2 squared plus 4 gives us 8. Plus, okay, we have c times x is 2. We have 2c plus d. And the x is 2. And this is 2 minus 1. Okay, so which is give us 1. Okay, 2 minus 1 here. Okay, so now solve this one. Now we have here, Okay, when the x is 2, right, on the left hand side we get 0. On the right hand side we will get 2c plus d. Okay, so 2c plus d. Okay, and this one we get -8, and we bring over, we get 8 here. Okay, so we solve this one. We have 2c plus d equals to 8. Now, from here we can see we actually have two equations. This is equation 1, and this is equation 2. Okay, how do we get these two equations? All right, by substitute two values of x. Now, beside -1 and 2, x equals to 2, you can actually substitute others value. Okay, we will still get two equations, and we can obtain the c and d by solving these two equations. Okay, so we write the two equations. Okay, so then if we plus this 2, minus this, okay, we can get the c is 2. Okay, subtract this, we can get the c is 2. And after that, we substitute back to here, and the c is 2. Then we get the d is 4. Okay, so finally, we can substitute the value of a, b, c, and d, okay, back to here, back to the partial fraction. All right, so we have, all right, this one, now it becomes something like this. Okay, so, and now we can actually integrate this. So integrate 2 over x, we get, what do we get? We get ln x. Okay, 2 ln x. And minus integrate 2 over x minus 1 will give us ln x minus 1. All right, 2 ln x minus 1. And integrate this one, of course, we will get ln x squared plus 4. Right, take note that this one, if we let this is the u, all right, this one will be the u prime. Okay, so we differentiate the u, we get this. Okay, now as for this one, 4 over x squared plus 4. Okay, so this one we can use the formula arctangent. All right, we get the arctangent x over 2. Okay, plus c. Now, so this is actually how we integrate by using the partial fraction. Okay, let us consider another example here. Now, if we have a polynomial like this, all right, x to the power 5 plus x to the power 4 minus x minus 1. Okay, how do we factorize this one and make a partial fraction? Okay, first, right, we can actually group this. Okay, we group this as one group, and this one has another group. Now, by grouping this one, we can see here, the first group, we can actually factorize out x to the power 4. Okay, we can factorize out x to the power 4. And so the first one, we have x. Okay, so x to the power 4 times x, we get x to the power 5. And the second one here, x to the power 4 is 1. All right, 1 times x to the power 4 is x to the power 4. Okay, for the second group here, we have negative x, negative 1. So we can factorize the negative out. Okay, so we get x plus 1 again. Now, after that, we can see we have another common factor here. X plus 1 is the common factor. So we can actually factorize out the x plus 1. So when we factorize out the x plus 1, right, the first term here remain x to the power 4. Okay, first term, after we take out the x plus 1, the first term here is x to the power 4. Minus the second one, after we take out x plus 1, we have 1 here. Okay, now after that, consider this one. Now, if you remember, right, we have a formula x squared minus y squared, or we say a squared minus b squared. Now, when we have something like this, we can actually factorize this into a okay, a plus b and a minus b. Now that we have x to the power of 4 minus 1, this is actually 1 to the power of 2. Okay, we can make it 1 square. So this is actually x square to the power of 2 minus 1 square. And clearly from here we can see this is the a, x squared is the a, and 1 is b. So when the x squared is a, 1 is b, so it can be factorized into a plus b, a minus b. And of course we will have x squared plus 1 and x squared minus 1. Okay, we have x squared plus 1, x squared minus 1. Okay, and furthermore, now let's look at the x squared minus 1. Now the x squared minus 1 is another form of a squared minus b squared, right? A squared minus 1. Okay, this one can be 1 squared again. So it's another form of a squared minus b squared. So we can factorize this one more time. Okay, we copy the x squared plus 1 here. And this, it become x plus 1, x minus 1. Okay, now, so for x to the power of 4 minus 1 here, now we replace this with these three factors, x squared plus 1, x plus 1, x minus 1 inside. Okay, so we have x squared plus 1, x minus 1, and because x plus 1 we have 2, so we have a square here. Okay, so we can fully factorize into this. Okay, now when come to the partial fraction here, okay, so we can actually change the denominator into the factors. Okay, and now we have the partial fraction like this. Okay, I want you to take note of the x plus 1 here. Now the x plus 1, this factor, because it is a square, so when we decompose into partial fraction, we need to make it 2 times. Okay, so this one is very important. Because of the square, we have to make it 2 times here. We need to have b over x plus 1 and c over x plus 1 squared. Okay. Now, as for x minus 1, of course, we have a over x minus 1. And for x squared plus 1 here, now since this is x squared, so when we create the numerator, it has to be dx plus e, 1 degree less than x squared. Okay, so this is the partial fraction. And then from here, we can proceed to find the a, b, c, d, and e, all right, by creating the basic equation with this one. Okay, so if this is 1, then we will actually create this equals to 1. If this is some function of x, then we will create the basic equation equals to the function here. So this is how we use the partial fraction to find the integration. So as a summary, we have actually three types here. Now the first type is when we have x minus 3, x minus 2. So this one we can decompose into x minus 3 plus x minus 2, a and b. Okay. Now the second type, all right, if we have, okay, x plus 1, x okay, for example, x squared plus 1. So this, it can be decomposed into x plus 1, the a here, plus, now this is x squared plus 1, so we need to have bx plus c. Okay, and the third one, if we have x plus 1 square and x minus 1, so we need to actually decompose this one to x plus 1 a plus x plus 1 square b and plus again, okay, x minus 1 c. Alright, so basically we can actually find the partial fraction for these three types, and further we use this partial fraction to solve for the integration.